So the digital audio, how to make that right now, as you can, as you saw before in the chapter about how to make the digital, as only digital analog, audio or analog the same. We must convert the analog to digital over here on this point. Sorry. So must convert the analog signal. So as I said, and the signal frequency domain is not one, but I think that's been taken by the words because almost dealing with that. Anyway, so as I said, to make it it's understandable to the device, and later to make that kind of value. How to make the sampling? It will be shown over here. Version A of the signal can show you the analog signal. Version B can show you the sampling. Over here, let me talk about that one. So let's say that we have this kind of signal. So I want to choose right now. I hope so. It will be really interesting for you. So I will show you right now how to choose the specific. We are facing any kind of trouble with the sound of my voice. I mean. Okay, so for belong to those person those people who is facing that kind of trouble with the sound. So make sure that your internet is okay with. Some of you could hear me very well, and I think there was no problem right now with my internet. Anyway, it's loud but not very clear, by the way, so you can reduce the volume in your PC. So you can hear very clearly, and I will inshallah reduce my volume by the way. Let me back to the lesson. As I said before, we have to make that kind of a discrete behavior. That kind of discrete signaling. So I will choose on a specific time. I will choose on a single amplitude of the signal like this. So let me put to the file something like this. I will choose at this specific time. This one, I will choose. Sorry, let me just only make the size a little bit much more. You can see. Sorry, let me put more like this. At this specific time, I will just only use single point like this. Like this. So, sorry. Because that kind of thing is a little bit. Somehow this one. Important thing is when you are choosing them. Important thing when you are going to make that kind of discrete, to make sure that you are gonna choosing the zero crossing. This point is called the zero crossing. This one, those two, this one, and this one as well. It will be called as a zero crossing because it's representing the termination of the signal. I mean the final part of the signal. So let's back again, and we're gonna make that kind of things. Okay. Sorry, I will make it very fast, like this. Sorry. Okay. It should be, in fact, the time it should be the same time between each point. This is the important thing. I mean, the kind of the synchronization, because the delta tau should be, I mean, how can we represent the discrete signal? We can represent it on an equation like this. So it will be something like sine. The signal will be, let's suppose that the signal is the whole signal is equal to sine of t plus delta tau. Delta tau, let's say dt tau. Okay, so will be equal to the delta tau should be the same. I mean, like s t. The delta should be 1, 2, 3, 4. I mean, as a sequence of a number, periodic sequence. I'm talking now about the time, the amplitude and time. A specific amplitude. Okay. What factor should be should in your mind that it is the relation between, and don't deal with this without them at the same time. Okay. What will be this? It will be s of t plus, let's say 1. This kind of the sigma here. This one, in fact, I'm sorry for that. I'm sorry. It's kind of message than usual. Okay. I think the equation shouldn't be like this. Okay, so in fact it will be s of t because it is equal to s of t plus 0, so it will be s of t plus the other sample. It will be s of t plus 1 as well. We continue plus s of t plus 2 and so on until we could get plus s of t plus n. Okay, and n is the final. Okay, and it will be the final point. Okay, d is the delta tau. It's not important to know that kind of the function that I'm just only writing it right now. I just want to represent for some of you that who could understand the mathematical representation for the signal. So I write this kind of the equation because this kind of the equation will represent, in fact, the how it will be, how we deal with that kind of things in mathematics. Okay. And later on I will show you an example how to make that kind of things belong to the I think the time is going on, so please let me finish and later I will give you the time to ask me when you all have down into the music to see sound of something, and we did that kind of things, and later on we choose at a specific time the points, so we have to choose, so we have to choose that kind of the grid like this over here. Over there, this will be called the quantization, to give the number to these points. Okay. Okay. Right now we have chosen the grade. It is in fact what we are saying, we have desecrated the time. Okay, we have been chosen the specific time, the amplitude. Now we have to desecrate also the amplitude that we call the quantization. So we have to give the quantity that belongs to it. The point will be given as a number. So at this if we say that at this point, sorry, this point is give a 0, is it? So it will be 0. Sorry. It will be equal to 0. Any point will cross this line, will cross. Sorry, just let me change the color. Any point will cross this line, or it will cross. Sorry. will cross the green line, as you see, will cross the green line, or it will be between any value less than those two lines, it will be considered as a zero. Okay? This is the meaning of the quantization. Any point in between the two green line. Let me change the color to make it red. I mean, like this. Okay? Any points or any value of the signal is between two these points, it will be considered as a zero. Okay? Or as well, we are going to talk about that line. Any points or any sample, because now I'm gonna talking in a scientific way, because you should understand. Any points between those, okay, line, the second two line to be considered as a 1, and as well this one and this one to be considered as a 3. Yes, this is the way that you can be sampled, and now we can convert those kind of things to the number using the quantization belong to the comparison that I've been doing right now, for example between the line that I just show you. Okay, so you can give it a number, and those number can be transferred later on into a digital, because now you know how to transfer from analog, the decimal to digital. I think that we'll be taking that kind of things, and I want to go ahead with it. So is it understand it? Can you understand it? I mean, is it clear for all of you? Not only 0 and 1, we have given, I mean, that kind of a number, because if it's the level, it will be 3, so we have to transfer that one into 1 0 or 1 1 belong to the decimal. To binary, transferring from the binary to decimal, so it will be belong to the binary signal. It will be belong to the number of the digit that I will choose. It will be belong to the number that you could get in the number of levels that you have been choosing. And the way it's not really important, or it's not so important for you to know more about it, or about how to make it, because that kind of thing is not, but I mean, not important in your subject in multimedia, but I will just give you that. But it's important to know about the sampling, how we could do it. That's what I'm gonna talking about, inshallah, in the next slide. Increasing the time or decreasing the time, and how it will show the signal, because we will lose some kind of detail as long as we are increasing the time, as long as we are decreasing the time between the sample, so we will get much detail about it, and we are going to talk about it in the next slide. I'll show it to you how it will be. Okay? There is any questions belong to that? I hope so that it's clear for all of you. What do you mean cannot see my typing? It's important to see the writing on the board, the whiteboard. Maybe belong to the bandwidth. I thought the bandwidth is also a new term that I want to talk about it, because anyway, we are going to be engineering, so we are not like normal people. We must see the bandwidth. Anyway, by the way, anyone who got any kind of confusing belong to that one, I will inshallah clear it for you later on. And I can, as I said before, I'm available on the Skype all the time. Any questions belong to any subject, I will be ready inshallah to answer. the value between the red line. Yes, I'm on the Skype. If you have problem with that one, I will be on the Yahoo Messenger as well. On both. But the official one is the Skype, because that's what they ask in the university. Anyway, for that we're asking between the value between the line. We have to choose a quantity for the to give the inshallah will be on the Yahoo. As I said, so just let me answer that the person who's asking about the confusing of the red line. As I said before, any value between those red lines, let me reduce it, any value between those red line that it is in front of you, okay, it will be given a zero value for any sample between those two lines. So if I choose any point over here like this, let me say this one, if I choose this value or this value or any value over here, so it will be given, it will be considered as a zero in decimal, because I should give a value or a number in another way to those points. So it will be converted into digital later on, but it's a decimal value, okay? So any value between those two lines like this, over here, over there, so it will be, or even over here like this, so it will be given as a zero, considered as a zero, okay? So let's go for the one who's asking, AD614, is it asking about what is the difference, if what will happen if we increase the timing, as it will be decreased. So let's see in the other slide what will happen. So as long as we are increasing the points, you can see over here, we have been increasing the time. Yeah, of course, we are dealing with the minus and the plus as well, and the minus, it will be considered as a digit, it will be negative of binder, 0 to it, it's 1, if it will get it, a digit, which it will be considered for the sign of the number. I think that when we taking that kind of things in the digital. Like if I want to convert, so let me just give you that kind of example, very simple before I'm going to start. If you want to convert this one, the decimal number, which is, let's say it is minus, what can we say, is minus 12. So in binary, it will be equal in binary. It will equal like this. Sorry. The 12 in fact is 1 0 1 1. Sorry, 0 0. Is it? The 12 without the sign, it will be equal to 1 1 0 0. Is it? Okay. Everybody with me? Okay, so on the left hand side, so we have to add a digit like 0 if it is positive, or 1 if it is negative. Okay, this is how can we represent that minus 12, while 12 only, or plus the positive 12, and by equal 1 0 0. Anyway, it's this is kind of example. You know, to the way that you want to choose one for the positive or for the negative. But this is just only an example to how to show you that how can you the negative and the positive. I think I have been taken that kind of before. Clear? Right now?